In the first part of the Viaducts presentation, we illustrated the opportunities that arise when considering the removal of the Georgia and Dunsmuir Viaduct. This portion of the presentation seeks to answer the most common question that this concept raises in people's minds. That is, what happens to all of the traffic that currently uses the viaducts to access the downtown? For those not familiar with the study area, this aerial photograph shows how well the viaducts connect east-west across the study area, and how poorly the streets at ground level, Expo and Pacific, connect east-west, with both streets taking an aggressive curve to essentially run north-south at the eastern boundary of this image. It is this lack of connectivity at the ground level which is the critical challenge to be overcome when considering removal of the viaducts. The blue and purple line work in this image is an overlay of a replacement road network which provides significant east-west movement capacity at the ground level and allows for removal of the viaducts without adversely affecting the ability of people and goods to access the downtown. In essence, this concept replaces the kilometer-long elevated viaducts, which have a total of 5 traffic lanes, with a much shorter 4-lane two-way ramp connection from Georgia to Pacific. Pacific is operated two-way east of Georgia Street and realigned north of the SkyTrain Guideway to connect east to Pryor and Venables, with intersections at Quebec and Maine. In addition to retaining the critical function of the viaducts, an east-west link with capacity for goods movement and commuter vehicles, this road network offers significant improvements for route choice and overall vehicular connectivity, improvements in wheelchair, pedestrian and cyclist facilities, opportunities for new bus routing, and it integrates this area of the city into the fabric of the downtown, a feat which would be significantly more challenging if the viaducts were to remain in their current configuration. To help the city understand the important role that the viaducts serve today, the city commissioned a license plate survey in 2011, the results of which are shown on this slide. The graphic is essentially showing where people are coming from that use the Dunsmuir Viaduct in the peak morning period. For those that can't read the numbers, darker shades indicate higher trip volumes. From this, it can be seen that approximately half of the total number of trips originate from the eastern half of the city of Vancouver, with another large proportion coming from the northeast sector. It can be assumed that these same people would make up the majority of traffic on the Georgia Viaduct in the afternoon peak period, on the reverse leg of their commute. The graphic clearly shows that there are a number of viable alternatives for people using the viaducts today, particularly those originating from the southeast. It is also important to note that of the people using the Dunsmuir Viaduct, roughly 85% are destined for the downtown core. 5% will travel over the Lionsgate Bridge to the North Shore, and 10% will travel over one of the other False Creek bridges to head west. The graphic presented here shows typical volume over a 24-hour period on the Georgia Viaduct in pink and the Dunsmuir Viaduct in blue. Taking Dunsmuir, you can see that traffic peaks between 8 and 9 AM at approximately 1,600 vehicles per hour, while Georgia peaks between 5 and 6 PM at approximately 2,000 vehicles per hour. If you count up the area beneath the curves, you get the total number of vehicles using the viaducts in a 24-hour period, approximately 40 to 45,000 vehicles. This represents 30% of the traffic crossing the downtown neck and 10% of the traffic entering or leaving the downtown. There is an important trend to note from this chart. Georgia carries more traffic than Dunsmuir, and the peak for Georgia is considerably higher than for Dunsmuir. Now this is due to a couple of factors. Firstly, peak afternoon traffic is generally larger than peak morning traffic, as in the morning we typically just have people going to work, whereas in the afternoon we have those same people reversing their trips to go home, but also an additional number of discretionary trips from people going out to meet friends, see a movie, and buy groceries, among other things. Georgia also has 3 full vehicular lanes as compared to Dunsmuir, which currently has 2. Some key assumptions were made in order to complete the transportation analysis. The analysis for the east and westbound directions was separated. In the subsequent slides, we will concentrate on the eastbound direction, as this has the higher peak volume and is the most challenging direction to accommodate. The key transportation metric we are using to describe the consequences of the proposed changes to the road network is termed the V/C ratio. Mathematically, this is expressed as the volume of traffic on a roadway divided by the theoretical capacity of that roadway. Essentially, it is a measure of congestion. The higher the V/C ratio, the more congested the roadway. Now, road congestion is felt or experienced by goods movement, by bus transit and commuters as travel time delay. It takes longer to get from point A to point B. Shown at the bottom of the slide is a schematic of the relationship between V/C ratio and travel time. For V/C ratios of 0.85 and lower, the roads are essentially in free-flow conditions with negligible difference in travel time. For V/C ratios between 0.85 and 0.95, there are moderate increases in travel time. And for V/C ratios above 0.95 and certainly above 1, there are considerable travel time impacts. From an engineering perspective, V/C ratios above 0.95 are not supportable for new infrastructure, as there are significant impacts to goods movement, bus transit, and the overall character and quality of our streets. So for the purposes of this analysis and for any potentially affected routes, a V/C ratio of 0.95 is taken as the maximum supportable threshold. For context, Main and Terminal today operates at approximately 1.1. Dunsmuir and Beatty in the peak AM period operates at about 1, and on some days, as you travel on Terminal heading east over Clark to First in the peak afternoon period, you may experience a V/C ratio of 1.2. One of the most important assumptions in the transportation analysis is what will happen to vehicle volumes in the future, when and after any changes to the viaducts are made. To help us answer this question, this graphic shows our historic trends for vehicles entering and leaving the downtown during peak periods from 1996 to 2011 in blue. As you can see, volumes have decreased significantly in that period. Statistically, approximately 15% over the last 15 years for peak periods, and 20% over the last 15 years for a full 24-hour period. It is important to note that this occurred while the city experienced a 75% increase in population downtown, a 25% increase in jobs, and a 15% increase in the total number of trips by all modes: walking, biking, transit, and car. So while the city has fewer cars entering the downtown today, there are significantly more people entering the downtown, which is the important parameter for a successful and vibrant downtown and economy. This trend of decreasing vehicle volumes is attributable to a number of factors, one of the most important being large-scale investment in high-capacity transit infrastructure, such as the Millennium and Canada lines, which facilitated a large-scale shift from private vehicle to mass transit. Projecting into the future and considering the EVERGREEN line is scheduled to be operational in 2016, and plans for further transit investments such as the Hastings B line, a UBC or Broadway line, and continued Expo line capacity upgrades and extension into Surrey, all of which would land in the general timeframe between 2020 and 2035, the city feels that it is a reasonable lower bound projection for vehicle volumes would be to simply extrapolate the historic trends of an approximate 1% decrease in vehicle volumes per year, up to some point in time, shown here as 2030, where we would consider we have reached minimum vehicle usage. This recognizes that there will always be a demand for private vehicles, as this is the most appropriate mode choice for many trips and many demographic groups. It is also important to note that this lower bound projection is consistent with our transportation plan and greenest city objectives. The decisions that the city makes today and will make tomorrow are all geared to achieving this lower bound trend. It is also prudent to consider a conservative upper bound to determine the sensitivity of the analysis. For the conservative upper bound, essentially a worst case scenario, which is shown in pink, vehicle volumes are simply capped at today's levels and projected forward indefinitely into the future. Graphically, you can see that this is a significant departure from the measured and repeated historic trends over the last 15 years. This graphic shows current peak hour vehicle volumes on our primary eastbound routes through the neck. These are routes that could potentially see redistribution of traffic as a result of the proposed road network changes. Canby southbound is also shown, as this acts as a pseudo-eastbound route. As if there is congestion in the neck or an accident, people naturally divert to Canby south before heading east. This presentation concentrates on the eastbound afternoon peak, as this is associated with the Georgia Viaduct, which has the highest peak vehicle volume and hence is the most challenging direction to accommodate. Evaluating the V/C ratio for these routes during peak periods today, we can see that they range from approximately 0.6 to 0.8, which means that we have reserve capacity to accommodate potential diversion of vehicles from the viaducts. Intuitively, this makes sense that we would have reserve capacity on our road network today, given that vehicle volumes have decreased 15% in the last 15 years. This graphic shows average Monday to Friday vehicle volumes on the Georgia Viaduct in green and Pacific Boulevard in blue, and the total cumulative demand of these two curves if you added them together in pink. The reason that we are combining the demands for Georgia and Pacific on this graphic is that this is essentially what we are proposing in our revised road network. We are attempting to channel vehicles which currently use the Georgia Viaduct down the Georgia ramp and then east along our new Pacific to Quebec, Maine, and onto Pryor and Venables. Shown dashed in blue is the capacity of our new Pacific at approximately 2,100 vehicles per hour. Graphically, any areas beneath the dashed capacity line represent vehicles using Pacific or Georgia today that can continue to use the new roads in the study area in the future after the viaducts are removed. Any areas above the dashed line represent vehicles which are potentially redistributed to other routes. Statistically, this potential redistribution represents less than 5% of traffic over a 24-hour period. Taking the peak PM period at 5:30 in the afternoon, the potential redistribution represents approximately 500 vehicles per hour. To put this number in perspective, a single lane of traffic can accommodate between 600 and 750 vehicles per hour. Returning back to our route network diagram for primary eastbound routes through the neck, this slide shows current peak hour vehicle volumes in black and brackets, and the expected vehicle volumes once the road network changes are implemented for the average Monday to Friday peak period in green. You will quickly note that the expected vehicle volumes are almost unchanged from today's volumes, with the exception of Pryor and Venables. A question in your mind might be, what has happened to the potential redistribution of 500 vehicles that was mentioned in the previous slide? In preparing this slide, we explicitly considered other initiatives planned to occur before or at the same time frame as the viaduct removal plan, specifically the EVERGREEN line, which conservatively is expected to draw approximately 600 vehicles from all routes through the neck. And if the Canada line experiences any indication, this number will be significantly higher. This modest shift from private vehicles to the new transit investment essentially counteracts the potential redistribution of vehicles as a result of the viaduct changes, and is expected to result in no net changes for routes through the neck. When discussing transportation impacts associated with the potential modifications to the viaducts, it is important to consider transit, as this has the largest potential to mitigate any negative impacts. Shown here is the Dunsmuir origin graphic with existing high-capacity transit lines superimposed. From this, we can see that the high-trip generating areas are all currently well served by transit. Looking forward to 2016, the earliest date for implementation of this scheme, the EVERGREEN line, as discussed in previous sections of this presentation, is shown in blue. As you can see, This significant investment passes through a number of the high trip generating areas for the viaducts, and the city feels strongly that this will facilitate a significant shift to transit for current users of routes through the neck, and will help ensure we continue our historic trends of decreasing vehicle volumes. It's important to remember that this concept is about much more than simply transportation. It's about creating opportunities for increased and improved park space, affordable housing, and reconnecting communities. It supports an appropriate investment in changes to our road network, which allows us to reduce maintenance costs, reduce the city's exposure to earthquake risk, and it forwards our Transportation 2040 objectives for active transportation and transit as modes of travel which will allow us to continue to grow the number of people entering and leaving the downtown while still providing critical capacity for goods movement.